Hey everyone, welcome back to convergence testing. We're now going to talk about the p-series, and then we're going to talk about two more types of convergence testing, direct comparison and limit comparison. Let's talk about a p-series. A p-series is anything that has 1 over n to the p. Okay? So the base is going and you have some power. So like 1 over x squared, 1 over x cubed, 1 over x to the fourth, something like that. By the way, a harmonic series is just 1 plus 1/2 plus 1/3 plus 1/4. A p-series converges if the power is greater than 1, but it diverges if the power is less than or equal to 1. So, what's that mean? This is a p-series. What's the power? The power is 3. 3 is greater than 1. It converges. That's all you have to say. Let's take a look at this one. This is a p-series. The power is 1/3. 1/3 is less than or equal to 1. It diverges. P-series makes the next couple problems much easier. Knowing that a p-series converges or diverges is extremely useful. What if it's 1 over n? That's power 1. 1 is equal to 1, it diverges. So the harmonic series diverges. The direct comparison test. This uses an easier series to test a more complicated series. Okay? So we're going to pick two series. And we're going to see which one's bigger and which one's smaller. Now you can read this. Pause it and read it. But here's the idea. You have two series. A big series and a small series. If the big series converges, it pushes the small series to convergence. If the small series diverges, it pushes the big series to divergence. So, if big converges, little converges. If small diverges, then big diverges. Okay? Let's take a look at an example. Let's compare this to something that we know. Let's compare it to 5 over 2n squared. Now wait a minute, how do I know that 5 over 2n squared does something? 5 over 2n squared is a p-series. I know it's got the 5 halves in it, but it still works. The power is 2. 2 is greater than 1, so this converges. Okay? I know this one converges. But think about this. This question that we have is smaller than this question that we know. How do I know this is smaller? Use some common sense. Ignore the tops. Which of the two bottoms is bigger? The left one's bigger because you're adding to it. But if the bottom is bigger, that means that the fraction is actually smaller. So I know that this one, the bigger one, converges. So what's that make my smaller one do? Because the bigger one converges, the smaller one has to converge too. Let me run through that again. We know this is a p-series and it converges. We know this is bigger than this because the bottom is bigger than this one, which means the fraction is smaller than this one. Because the bigger one converges, it forces the little one to converge. Let's take a look at this. This is a power series. Let's compare it to 1 over 2 to the n. This converges. How do I know? It's geometric. It's not power. That's 1/2 plus 1/4 plus 1/8 plus 1/16. That converges. Why? Because r is less than 1. So what are we going to compare? We're going to take the thing that we know, which converges, and we're going to compare it to the thing we don't know. Which of those two is bigger? Well, if it wasn't a fraction, this number is bigger than that number. But because this bottom is bigger than this, that means that the fraction is actually smaller. If the bigger thing converges, then it forces the little one to converge. So, 1 over 2 to the n plus 1 is convergent. the limit comparison test. This is more powerful than the direct comparison test. So if the direct comparison test doesn't work or you can't use it, we're going to use the limit comparison test. And by being more powerful, it's more complicated. We use this with messy problems. Problems that aren't easy to look at. This one is very easy to look at because it's all addition, so I know it's smaller. This is addition, so I know it's smaller. But what about ones that aren't so pretty? Choose a p-series with the nth term of the same magnitude as the nth term of the given series. I'll show you what I mean in a second. Pay attention to the wording here. I'm going to do one of them divided by the other and take an infinite limit if that gives me a number. If that gives me a number, they both either converge or they both diverge. So I'm going to pick something I know, divide it by the problem that I have. If that gives me a number, then they both converge or both diverge. Let's take a look at this. What should I compare this to? Well, I can't compare it to 1 over 3 n squared. I know 1 over 3 n squared converges. It's a power series. But I don't know which of these two is bigger. If that was all addition, then that bottom would be bigger, which makes it smaller. But because it's got addition and subtraction, I don't know. So I cannot do direct comparison. Direct comparison does not work here. So I'm going to use 1 over n squared. Why do I want to use 1 over n squared? Because I know this converges. How do I know it converges? It's a p-series with a power greater than 1. So I'm going to do a limit as n goes to infinity, and it does not matter which one you put on top. This is the one I know. This is the one I'm trying to figure out. Clean that up. You get the limit as n goes to infinity of 3n squared minus 4n plus 5 over n squared. And this answer is 3. So I got a number that's not 0 and it's not infinity. So that means they both do something. But I know this one converges, so then they both must converge. I took one that I knew. I took an infinite limit of 1 divided by the other. I got a number that wasn't 0 or infinity. That means they both do the same thing. And since that one converges, that one converges. Let's take a look at this one. What do I want to compare it to? Let's compare it to 1 over the square root of n, or 1 over n to the 1/2. Why do I want to do that? Well, that's an easy power series, an easy p-series. Does this converge or diverge? This diverges since 1/2 is less than or equal to 1. So I know that this one diverges. Let's do an infinite limit. Doesn't matter which one you put on top. Which one you put on bottom. That's the square root of 3n minus 1 over square root of n. That's the limit as n goes to infinity of the square root of 3n minus 1 over n. What's the power on top and bottom? It's 1/2 and it's 1/2. This is same over same. If it's same over same, I look at the numbers in front. I get 3. Because I get a number that's not 0 or infinity, they both must do the same thing. In this case, they both diverge, since the one that I knew diverged. Okay? Be very specific about what they're saying. So we had 3 things today. P-series, 1 over n to a power. If the power is bigger than 1, it converges. If it's 1 or less, it diverges. Direct comparison. If the bigger one converges, the smaller one converges. If the smaller one diverges, the bigger one diverges. Limit comparison test. If you can't figure out which one's big and which one's small, do the limit of the one you know divided by the one you want. If you get a number, they both are the same. They both converge or they both diverge. Okay? Last testings next time.